All right, let's have a look at question 2c. Now, I've actually I had one of my students asked me a little bit about this one, and I was just demonstrating what it meant for, in this case, a cubic to have a decreasing function. So what this is about here, we have a function, it's a cubic, and we've got to find the values for which it is decreasing. And in a cubic, so for example, if this was, say, a positive cubic, so it's increasing here, and in other words, the gradient's positive here, gradient's positive here, gradient's positive here, all the way up to the very top, and the gradient's only 0. And then it turns around the corner, and then it starts decreasing, 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 and so on, yeah? And then when it gets to the bottom again, it then can start increasing, increasing, and increasing. What do I mean by increasing? If the gradient is like this, m is 0. That's a stationary point, it's a turning point, it is a maximum or minimum point, and the gradient is 0. What does it mean if the gradient is on an angle like this? Well, it means that m is positive. In other words, it's increasing. The function at that point is increasing in value. Of course, if it's going that way, then m is negative, and it's decreasing. So for a positive, one of these, a positive cubic, it's going to be between the maximum and the minimum, it's going to be decreasing. This point from here to here is decreasing. And if it was a negative cubic like this, between this point and this point, it's decreasing here. It's decreasing. Between these points, it's going to be increasing. In other words, it's got a positive gradient. So that's how that plays out. And we can actually show that as well when we look at the differential of that. And you'll see that in just a moment. So let's have a crack at doing this one here. So I've got g of x. Where is it? G of x is that thing there. I'm going to write that all out. So I've got g of x is equal to x cubed minus 9x squared plus 24x minus 8. Let's find the differential of that, and we're going to find the differential because I want to find these two critical values here. I want to find the values when it's 0. Yeah, because if we find the 0 values, then everything, we're just looking at the points in between those. So if I went g prime x, that's going to be 3x squared minus 18x plus 24. Now, if I make it equal to 0, then obviously I'm going to be talking about the points with the gradient 0. In other words, they're these things here, yeah? So in this case, it's going to be, oh, and I can divide all this by 3 as well. Look at that. This is going to be x squared minus, this is going to be 3x. This is going to be 3, it's a 24. So I can, I've just divided everything by 3. But I can factorize this now. 0 is equal to, and I'm going to have an x and an x. Signs are the same, both negative, and it's a 2 and a 4 will work. So either x is 2 or 4. Now what does that tell us? Let's have a look. So these are the 2 points. We've got a 2 here, I've got a 4 here, and it crosses at 8. That's on my 8 there. But what have we found here? If we go down like this, here we go. We've got this bit below the x-axis. If there is a part below the x-axis, it means between these 2 points here, this indicates a decrease, indicates decrease. So what does it say? Yeah, it indicates decreasing function. Yeah. So for g of x, yeah. So therefore we could say, and let's make a little statement here. What do we say? Section below x-axis delineates. What should we say? section, I'll put, of g of x, which is decreasing, and then we'll put in brackets between, and it's going to be x is going to be less than 4 and greater than 2. And that's really what we found. So that's one way of doing this. We could also actually just plonk it into a calculator. And if you've got a graphics calculator, in fact, let's do that now. Here's the graphics. Here's just one of the Casio graphics. I'm actually going to go to 3 here. And we can actually draw in the function here. So we can put this function here into the calculator. Let's do that now. And you can actually see what it looks like. Now there's a reason why you want to do that. So I'm going to go x, let's have a look. So it's going to be x to the power of 3 minus 9x squared. I'm not very good at this, by the way. Plus 24x minus 8. So let's go draw. And there it is. So what we've found, so this thing here, now I'm going to actually draw it up here. So what we've actually got here is a graph that looks like this. It's going to go down, and it's going to cut at minus 8. So it's going to go like this. It's going to go like this and head up like that, yeah? So this point here, we've discovered, and that's what the 2 is here. So that's 2. And this point here is 4. And we said between 2 and 4, it's decreasing, yeah? Now we can also check that by taking a point either side. Well, that's 2 and that's 4. What about checking a point in 3? Let's make x 3 and see if it's decreasing. So if we take the differential, and the differential is this one here. So we've got g, so I'll put here check x equals 3. So I'll go like this, yeah, here we go. So it's g of 3 is equal, that's 3, sorry, the prime, g prime 3, which is going to be x squared minus 6x plus 8, which is x squared, that's going to be 3 squared minus 6 times 3 plus 8. And what we're doing is we're saying, is this going to have a value which indicates it's decreasing, yeah? Okay, so let's have a look and see if that's true. In other words, is the gradient in here at the number 3, if we put a 3 in there, is that a negative gradient? Well, you can see it's a negative gradient because it's going to be like on an angle like this going down there. But let's see if it is, yeah? So that's equal to 9 squared minus 18 plus 8. Let's have a look. Oh, sorry, not 9 squared, 9. Crikey. Well, let's have a look. Well, 9 and 8 is 17 minus 8. 18 is negative 1. So we can say, therefore, m is decreasing. Yeah? Let's check another one. Let's check on 1. Let's put a 1 in here, yeah? There's a 1. So check x equals 1. So g prime 1 is equal to, now here it should be increasing, yeah? There should be an increasing value here. That should be increasing gradient. Let's check it. So I'm going to have 1 squared minus 6 times 1 plus 8. So that's going to equal 1 minus 6 plus 8. So 1 minus 6 is 5, plus 8 is 3. 3. So it's a positive gradient. Therefore, m is increasing. Yeah? And so in other words, we've now checked here, it's increasing, here it's decreasing. So if you checked on the other side of 4, over here, like a 5 or something, or 6 or 7, you're going to find, therefore, the gradient is going to be, well, the gradient's going to be increasing here. So we've made our case now, and so we can say, therefore, function g, or g of x, we'll say, is only decreasing between 2x equals 2 and 4. And we've already had we made our inequality here. And here's our inequality. But that's the way that I would write that. So there's several checks you can make. This alone is good enough. But if you want to go ahead, you could do this one instead of. I wouldn't do both, but it gives a reasonable idea that you understand what you're doing and shows the examiner that you've got a command of this particular type of question.